Hello everyone and welcome to another episode of Nathan Builds Robots. Today we're going to be taking a look at the Snapmaker U2. I've had it for a couple of weeks and have printed a couple test prints just so I could formulate my own opinions about it and share them with you. And I gotta say I'm quite impressed with what this little machine can do. They had an outstanding Kickstarter performance and I guess they had a couple more machines to send out, so they sent one my way and they actually sponsored this video. But they didn't give me any instruction on what to do, so I'm just gonna review this classic style. I'm gonna show you everything I printed, all the little hiccups and errors that I had, and what I think this printer means for the 3D printer market. And if you want to jump to the conclusion, I think this machine is fantastic, absolutely amazing. I think it's the printer that Bambu Lab should have made with all of the massive amounts of R&D money that they have, but they didn't. Let's talk about setup, test prints, and just the general user experience of this machine. So after unboxing this machine and throwing away all that packing material, the first thing that you're going to want to do is find the instruction manual and the user guidelines and throw those away. Actually, hold on. You should probably read those. There's some good information in there. But I wanted to make sure that this machine passed the Nathan Builds Robots idiot test, so I haven't even cracked these open. I just kind of put things together the way that it looks like things should be put together. So if you're illiterate, you'll probably be able to get this thing put together no problem. If you want to make your life easier, I would recommend going through these user instructions. They're super simple to read and they give you a good explanation of how these things work. Basically, you're going to have to individually unpack these tool heads and get them installed in the right place. It's pretty simple. They're just held in place with magnets and a couple of rods for alignment. And then you plug in the USB-C cords and these Bowden tubes which guide the filament, and then you're pretty much ready to go. Altogether, the process took about half an hour, and if I read the instructions first, it'd probably take me about 20 minutes. Once you've got all the tool heads plugged in, you're going to take this sheet off and behold the heated bed. The nice thing about this heated bed is that they're using real magnets here that hold on quite strongly to your spring steel sheet. And then there's a little calibration feature over here in the back, and it touches each nozzle for each tool head to finish the calibration and get everything working correctly. One thing that I was pleasantly surprised about with this machine is the print volume. It's 270 by 270 by 270. So it's almost as big as your typical large format 3D printer, which is usually about 300 millimeters cubed. But this one, being 270, is just a tiny bit smaller. So I'm going to call this a medium large printer. To put it in slightly more relatable terms, it's slightly bigger than a basketball. I don't play many sports, and I think most of you are competitive 3D printer people, I guess. So I don't know. It's pretty big. Most of this is injection molded plastic panels that are covering up a stamped steel construction. So it's nice and sturdy. It's relatively light. Let's see. Yeah, I can pick this up and move it around no problem. It's a little heavy, but you know, nothing too difficult to deal with. Yeah, pretty solid construction overall. The glass door, some people might complain that you can't swing this thing all the way open, but you know, this is all you really need to be able to get in here, take your prints out, do your thing, and then put everything back away. And there's a quirky little feature here. You've got this handy little back window, which it's nice and airy and it lets some light in, so that's pretty pleasant. Not sure that this is the most useful window, but any additional visibility is always welcome. The right and left-hand sides of this machine are completely covered with these plastic panels, and that's actually where you attach all of your spools. I found this extremely ergonomic to work with. You can just change your filaments out by pulling these off the sides and doing the unload and load procedure. It's got little combination filament detectors and gearboxes on the sides there, so you can go ahead and feed your filament no problem. You never have to worry about getting access to the back of the machine and having to flip this around in case you have it pushed back up against a wall. It's really nice and easy to access everything, so I like that. Some of you might be wondering if you can plug in one of these dry boxes and feed your filament directly from a dry box, and I'm pretty sure you could. All you'd have to do is take the filament out one of these front ports and feed it in over there into the little drive gearbox, and it'll suck that filament in no problem. The nice thing about a tool changer design is when you're doing retractions and changing filament out, it doesn't have to unwind the entire length of filament that's going to the tool head. It just retracts a tiny bit, maybe a couple centimeters, and then parks the tool head and switches to the other material without having to do that big long rewind procedure that a lot of the AMS or CMS systems do. All of the mechanical bits are cleverly hidden away in the left and right hand sides of this machine. So it's all covered by these panels. In a lot of 3D printers, when you look inside, you can see the lead screws and the belts and all that kind of stuff. But in this one, it's all covered up by these panels. So it's a nice clean look, and you're not gonna get filament or parts stuck in there as easily. You're not gonna accidentally brush your sleeve up against it and get grease on your clothes or on your hands. So I like that everything is nice and tucked away there. Also, we've got some nice embedded lights over here on the side. Those do a great job of lighting up your workplace. When it goes to pick up a tool head, it just kind of goes to the back and does a little sideways move, and that clamps the tool head on there. And it's got a pretty clever system. It seems pretty low cost. It's just like these little ball bearings that are embedded into these die-cast pieces. This might be a little ball bearing that they insert into the die-cast, and then it squishes out molten metal around it and retains those in place. And that gives you a nice spherical surface to do repeated connections and disconnections from the other side of the tool changer. Let's put it away like this. And the magnets just hold it in place when you unclip it there. You can actually pull these off the magnets if you really want to mess with things and, you know, take a look at the tool heads. But for the most part, you never have to deal with that. It just automatically handles everything, and the magnets are strong enough to hold it in place unless you were to drop the thing. So try not to drop it. On the other side of the tool changer, we've got this little system over here. I'm not going to do a total deep dive into this, but it does make me quite happy. Anyone who's studied tolerances and GD&T would be happy to see this. It's a very precise system here where you've got a pair of 2 dowel pins that basically clip onto each one of these ball bearings. And yeah, so each one of those ball bearings falls into place nice and repeatedly, and you don't have to worry about it. The fan is located on this tool changer holder, so it uses the same fan for most of the operations. And let's see, we should have yeah, we've got another fan on here and kind of a Bambu Lab style hot end on the end here. So everything's nice and compact. These tools should be relatively inexpensive to replace and fix if you have any issues. I mean, they're mass producing these things in 4 times the quantity that they would in a normal 3D printer. So yeah, they're gonna get their unit cost down as much as possible on these little assemblies. If you ever need to replace something, let's say you have a massive hot end blob of death that really just destroys the whole tool, well, you can just unplug the USB cable, unplug the Bowden tube, throw this in the trash, or I mean, try to refurbish it if you can. But yeah, you can just swap it out with another thing and get running again. I'm sure there's probably some way that you can keep using it even if one of these tool heads is broken, because you've still got 3 good tool heads to work with. So I'm a pretty big fan of the mechanical design of this machine. The filament paths are nice and clean. It's really easy to use. We've got this touchscreen interface on the front, and this is something I want to give a shout out to Snapmaker for. I actually really like the way that this is just embedded flush into the panel here. I know some people might prefer being able to tip it up and down in case you have it up on the top of your refrigerator or something and you need to reach it, or you have it down on the floor underneath your couch. Then maybe you would want an articulating screen that you can pull out. But for most people, this is going to be great, and it avoids a common point of failure, which I've actually experienced with some of my Creality machines. When I'm moving them, sometimes those displays that are sticking off the side can get knocked off, and you can get the cable torn. And it's just one more thing that you have to plug in and set up when you're unboxing the printer. I actually really highly prefer having something that is not likely to get damaged and is just embedded in here. It's one of those smart decisions that they made in terms of packaging and keeping things slim and simple. And overall, this thing has a very slim and minimalistic vibe for how complicated of a machine it is. I mean, it's a tool changer, which is inherently complex. You've got a lot of different extruders and hot ends and stuff, but they've boiled it down to its most basic parts, and it's really easy to understand how the whole machine works. One thing that I want to point out here is these tool heads all have their own USB cable. So technically all of these can heat and extrude filament at the same time, but you're only ever using one at a time. These little 3 pogo pins right here are not that important. I think all they're doing is just delivering power to this fan. So you'll have a positive, a negative, and a PWM pin. It's quite a basic signal that you have to get from point A to point B, but since there's no wires going directly to this thing, you have to transmit that to it somehow. I think pogo pins are perfectly fine here, and Worst case, they fail after, let's say, 1,000,000 cycles of installing and uninstalling the tool head. Well, you should be able to fix that pretty easily. It's just a little connector bit up here, or maybe you have to replace the whole tool head. In any case, it's not something I'm going to be worrying about. And if you did lose your part cooling fan, I mean, you can still print without a part cooling fan. They have a lot of nice touches in terms of usability. Like here, you can see I can sweep out all of the gunk that builds up in the bottom of the printer just from these little purge lines. Technically, they shouldn't be building up down there, but what I do is they deposit the purge line at the front of this bed and I just flick them off and then they land down here somewhere. I guess you could install like a little bin down here and it would just collect those as you flick them off the front. It'd land in a little bin. But I'm happy with just sweeping them out occasionally. Not a big deal. Around the back, you can see the purge bucket. And this is basically all the waste that you produce. It's just a tiny amount. I've done a couple days of printing on this machine, and that's all the waste that I have. It's just a really small amount. I mean, it's probably a couple of grams of waste in there. Really not bad. And you probably have to dump that out once a month if you're doing a lot of printing. Over here you can see the prints that I've run. I'll do a detailed look at all this stuff in a little bit. But let's go ahead and start up a print and do some decibel tests. I know I love doing my decibel tests. So we just go to the user interface, press start, go ahead and hit next. It automatically assigns filaments, and we're gonna go ahead and hit print. There's a bunch of options for extra calibrations, but I'm not gonna do those. I think this machine is solid enough that I don't really have to do the adaptive bed mesh every time. That's definitely one of the more entertaining parts of this machine is watching these tool changers, just make sure everything is connected properly. While this is getting ready, let's take a look at the slicer, see what's going on over there, because that's something I actually really like about this machine. These are just a sample of some of the test prints that I've sliced and printed on this machine. Over here, I did a typical use case where you might have a bunch of different parts with a bunch of different colors. And there's basically no penalty for picking whatever color I wanted for these different objects. Normally, you'd have to worry about purging between parts and wasting a ton of material. But for this, it barely generates any waste, just loaded up with a bunch of different colored parts. This was a trash bin that I downloaded from the Prusa website, Printables. And this was a nice test print. I've got it over here. It didn't come out perfect. That's one of the things that I learned is when you're assigning colors to things, it gets kind of complicated when you're dealing with individual bodies. So maybe I can speak to that a little bit later. Here's a demonstration of how big the print volume is. We've got a basketball and it fits within the print volume pretty comfortably. You know, you see I can move it around a little bit and it still fits. So it's a little bit bigger than a basketball. Then over here we have my dummy 13 model that I printed out. Now I'm not going to put this thing together because it looks really complicated. It'd probably take me longer to put this dummy together than the 3D printer I'm reviewing today. So we're just going to go ahead and leave that as is. But this was another demonstration of being able to just load up a bunch of parts and picking whatever color you want with this thing. And again, swapping between colors has almost no penalty, so why not? Over here, I just tried painting all different surfaces of this model, all different colors, just to really test the resolution and see where this thing would break down. By far, my favorite thing about this slicer is that instead of having Snapmaker go ahead and try and design their own slicer and come up with something completely new and different, instead of doing that, they just base their whole project off of Orca Slicer. And the nice thing about that is that we're going to get all sorts of improvements from the Snapmaker ecosystem being folded back into open source projects. I know people that use Bambu printers, Prusa printers, Creality printers. They all like using Orca Slicer. It's kind of like the Switzerland of slicers. It remains neutral and works with every 3D printer brand. And in my case, I've got, you know, all sorts of different 3D printers. So having the option to run them all using the same slicer is a big bonus. And the benefit to open source doesn't end there. From what I've heard, they're using Clipper to run this whole machine and the web interface. They're going to be contributing back to these open source projects by contributing the code and all the other stuff that they developed to make this machine, which means we're going to get better routines for running all these multi-tool head type of things. I hope they continue to do this and even take it one step further and open up the tool mount protocols that they're using so that we can have third parties develop their own tool heads that can integrate onto this machine. There's tons of third parties that are really passionate about hot end and extruder design, so why not just let them develop their own thing that they could plug into this little USB port up here, and people can just go out and buy a $100 upgraded hot end if they want to get some new fancy features. Or let's say there's a chocolate or a solder paste or a carbon fiber toe laying tool head that you could install on this thing. Snapmaker wouldn't even have to develop it themselves. They could just open up the tool changer protocol, let other people develop it, and then that encourages people to buy into this ecosystem because you can buy this machine and then replace it with whatever type of tool heads you want to put on there. But enough about that rant. Let's see what's going on with this print. As you can see, the printer is quite fast. It's got a nice rigid frame here. They're using carbon fiber rods instead of steel rods, which helps keep that gantry nice and light. It's almost identical to a Bambu Lab printer that I took apart in the past. So you're going to have issues with serviceability. You won't be able to replace these individual components, but those don't fail all that often. And when you eventually do need to replace them, but I think I should be able to just rip off this top piece and get access to all the stuff under there if I needed to go and service something. This machine seems to be designed at least somewhat with serviceability in mind. I mean, first of all, the most common thing to break on one of these printers is the tool head. So the nice thing about this is, since you've got 4 tool heads on here, you can break 3 of them and the machine should still work. And then when it comes to replacing them, instead of having to go in and undo a bunch of wiring connections and pull a bunch of things apart, all you have to do is pluck that off like a little grenade, pop off the little USB port, plug a new one in, and then you should be back up and running after doing a short calibration so that it calculates the offsets correctly. So now I want to go through my test prints and show you what I've been printing with this machine. It's not all great. I mean, there's been some learnings along the way, some little print quality issues that I had. And this mostly comes down to just learning how to apply multicolor printing. I haven't done a lot of multicolor printing myself, and I've been entering into some advanced topics, so there's some learnings that I've had along the way. Let's take a closer look. So the first test print I will draw your attention to is the only one that comes preloaded on the machine. It's this little cute little dragon thing. And I'm actually printing another one of those out right now. And this machine has great speeds and accelerations. It's as fast as pretty much all the machines on the market. We're really hitting a plateau in terms of print head speeds now. And this thing is able to surpass it in overall print speeds because it's not wasting time purging material in between prints. So again, let's look back at this little dragon thing. Print quality turned out great. You don't have any bleeding between colors here because you have completely different tool heads that are processing the black and the white filament. So you got a nice, clean, crisp transition there. And we've got our reds and yellows and black and all that mixed together. And I'm going to go ahead and try and break this. It's spiky, so it kind of hurts. It's pretty strong. Okay, hold on. Let me get a hammer for this. Okay, so here's our little dragon head, and let's take a look on the inside. Overall, I mean, that was a pretty strong hit that it took to break this apart. Print strength seems pretty good. Print quality is up there. We got really steep overhangs here that turned out quite nice. So overall, I give this a 9 out of 10 for print quality. I apologize for the horrendous white balance. We've got a lot of different colors going on here with the blue and the red and the yellow. So my camera's getting a little confused. But let's continue with this. So let's take a look at these catapult prints that I did. These print flat, and then you fold it into shape. And then you're supposed to attach a little rubber band here, and you can start flinging stuff. I'll go ahead and throw this little hand that I printed and see what happens. That works pretty good. For this part, everything turned out really nice. Articulating mechanisms work pretty good. So the tolerances must be pretty decent. Here's a little tool that I printed out so you can cut out little microfiber rag strips and clean your printed beds off, which I should probably do for this machine because I had a couple issues probably due to my greasy hands and not cleaning the machine. So yeah, we'll look into getting this set up and cleaning some things. Here's another part of that assembly. You can see I just painted tiny little features on here, a different color, and I had different colors all over the place on this little print. everything turned out pretty good. I guess there's one little spot where I might have wanted to have the printer slow down or over extrude a little bit on that feature, but overall pretty nice. I think I might be expecting too much here because, oh, I think I was supposed to print this the other way around like this, but I printed it upside down. So yeah, I guess next time I'd try it like this, but it still turned out pretty good. All right, let's go ahead and set that down. I think I need to get some real scissors. Okay, now I've got this little scrubby brush that I can wipe off my my different build plates with little microfiber rags. Then I've got a little soap dish over here. I can set this in. I did absolutely an insane amount of color changes. I just colored things the different colors that I wanted, and they all turned out pretty good. This is kind of the limits of how small of features you can print with 0.4 millimeter nozzle. I think I was just asking it to print too many different colors in a tiny little area, so I got a little confused there. But for everything else, it worked really good. Now this is a print that I had quite a bit of struggles with. Okay, so one issue right away is this is not connected to the sidewall here. Normally, when you look at one of these prints, there's this really clever system of interlocking filament here. So you just have a little bit of yellow color on the outside, but when you actually cut into this thing, you can see the yellow goes quite deep into this part. It goes in like all the way to the center of the part. So your multicolor prints usually end up a little bit heavier and stronger because they're trying to really lock those two different colors together. When I printed this out, this little yellow piece was just a different entity. It was a different STL file that all got loaded up together. And it was located right up flush against this red piece. And it didn't quite understand how to lock these two materials together. So it just printed them in the right spot, but not really locking together. So now that just comes loose like that. Not great. This one, these seem to hold on pretty good. And same with this stuff on the front. So I think for this 3D model, it just requires a little bit of extra tuning. And you know, I manually colored these and I didn't do the best job either. So let's try and pull this yellow feature off the front, see if it'll go. Oh! Okay. Well, that one stuck pretty well. But for some reason this one didn't. I wonder if there's like a little gap. Like technically it wasn't touching in the slicer or something like that. Because this yellow one stuck to, oh yeah, that one popped off as well. This one looks like the yellow goes deeper down into that material. Let's get to the bottom of this. There. But yeah, that's just one of the challenges that you're going to come across when you manually design your multicolor prints. When you're doing this whole thing in CAD where you're setting it up as multiple independent bodies that you export in the same coordinate space and then load up into the slicer. Like it just gets really complicated. Versus when you're just painting models, it usually comes out pretty good. Okay, and this is the total amount of 3D printed waste that I produced for all of these parts. As you can see on some of the smaller print jobs, it is basically nothing. On some of the larger print jobs, again, it's basically nothing. There's basically, I mean, a tiny amount of material here. This one required a lot of color changes. I'm not sure which model this was. Oh yeah, this was probably the Dragon. That's about the right height for that. So it had a lot of colors and a lot of color changes and it produced about this much waste. And then this was a really cool print that I want to tell you about. Okay, so most of you can probably tell what this is. It's a slingshot, right? So I designed this in SolidWorks and I basically had this PIBA part, this flexible plastic part, interlocking with this PLA part. So the way that it's designed to work is you hold it like this, you get a little projectile. In this case, I'll get my little dragon head, and we're supposed to pull this back and launch it. But there's one problem here, and that's this PIBA sling is way too stiff. I can't actually stretch it back and launch anything. If I try, let's just get this little plastic knob and see what happens. I'm gonna pull this back. That didn't really work. But I found a secondary use for this. Basically, this kind of loads up and shoots like a catapult. So I found that I could actually launch stuff with the slingshot, just not the way that I intended. It shoots things pretty energetically. So if I scaled this up, I could start launching things pretty well with it. Like imagine this scaled up to the entire print volume of that Snapmaker. I could probably throw a baseball across the room or something like that. And then the other thing that I found interesting is this is interlocking PLA and PBA, and I printed it in this orientation. So this is my little purge block. But this little purge block exhibits some really interesting behavior. So take a look at it. It's just interwoven yellow and red layers, just like this part over here. This is yellow and red PLA, so it just acts like PLA. But this is interwoven yellow and red PBA. The yellow is PBA and the red is PLA. So when I try to squish it, I'm squeezing this, it's pretty stiff. When I try to squeeze it this way, or this way, it's also pretty stiff. But when I try to twist it, it's super flexible. And it's only when I try to twist it like this that it is super flexible. If I try to bend it like this, it doesn't want to bend that much. Or like this, again, not very bendy. But when I twist it, it acts like a deck of cards or something. I don't know if that makes sense to all of you. But yeah, it's super flexible in this direction. And that's where this machine presents kind of an interesting value proposition to different customers. Because you can use it kind of like a dummy, just take these normal multicolor printer projects and print them out with almost zero waste and no downtime between colors. So there's huge advantages to it if you just want to use it like a typical multicolor printer. It's basically running how you would expect a multicolor printer to work. Just effortlessly switching between colors and letting you paint your models with whichever colors you feel like, without having to deal with an enormous mountain of waste at the end of every print job. So yeah, you can use this as a basic user and you're going to get some huge benefits out of it in terms of just ease of use, reduction of waste, increased print speeds by sometimes a very significant amount. And some prints it can be 4 to 5 times faster. People who are just printing basic stuff or running a print farm where the amount of filament that you end up throwing away really matters will get a lot of benefit out of using a machine like this. But also more advanced users. I have a degree in mechanical engineering, and these type of multi-material prints fascinate me, and I wanted to do more experiments with it. But what I found is that it's actually extremely difficult to get this stuff to work, to learn how to effectively design multi-material prints. It's a pretty advanced CAD user operation where you have to split your objects into different material zones, export it as multiple different bodies, and you also have to have a good understanding of the engineering calculations to make things like this work. So it requires a lot of trial and error, and you're going to have to learn to dial in your printer for these multi-material thingies, but it presents a super interesting challenge to anyone who's more mechanically inclined or really wants to do some more advanced design work. Like, you could spend a ton of time designing super advanced products that have rubbery grips. I mean, that's pretty common in power tools, like this little cutty thing that I have. It's got an overmolded rubber grip with a glass fiber reinforced ABS or something like that. Maybe it's a polycarbonate so that it's super tough and you can drop these things, and they're super stiff so that it's not wiggling around in your hand while you're using it. But you've also got these rubberized grips to make it really easy to hold on to. It presents a really big challenge to anyone who wants to rise to the occasion and develop more advanced 3D prints. And that's where I ran into some issues, because I just didn't have enough time to really sit down and do the really detailed CAD work to make all this stuff work. Unless you're designing parts to be 3D printed full time, or you're an extremely enthusiastic hobbyist, you're probably not going to have the time to sit down and just really work through all these little design issues. Really, it's like an engineering type job to just make these 3D printable things out of multiple materials. But I think there's a ton of possibilities here, and it's something that I really want to explore more with this machine. The huge thing about this compared to other tool changer systems on the market, including the up-and-coming newly released Bambu Lab product, the main difference to me is that this machine is going to be inherently better at printing super flexible materials. Like this, I think this is 90A durometer PBA. I barely had to slow this machine down at all to be able to print that super flexible material. And I think that's one of the most interesting applications for a printer like this, is to be able to print those flexible materials and combine them with harder materials to make really interesting functional parts. So if you're up for that challenge, then I'd recommend picking up one of these machines and opening up SolidWorks or Fusion 360 or Onshape, whatever your CAD program of choice is, and really trying to design some of these flexible, multifunctional, multi-material models. We finally have a machine on the market that's affordable and able to print these things really quickly and easily. And yeah, I think it'll open a lot of doors for interesting things for people to print. The other thing that you need for a printer like this to be successful is that you need stuff to print. So we really need designers and stuff like that to come up with those files and models to share with each other and to print out. And that's where a machine like this, with its super successful Kickstarter and mass adoption, I mean, it's coming in at a price point that frankly is hard to believe. That means that this machine is going to be in a ton of people's hands, and they'll be able to design a lot of different models for you to be able to try out on your own printer. But again, if you're not feeling advanced, if you're not feeling fancy, you can just go ahead and print basic multicolor stuff like this, and you're still going to see huge benefits in terms of print speed and waste reduction. So in short, I think this really is the machine that Bambu Lab should have built. They were on a roll of copying all of Prusa's ideas until they got to the H2D, which was like this overly complicated two-tool head system. I don't call that a multi-material printer. I call that a two-material printer. This is a true multi-material printer. I mean, it's not really. I mean, it's a four-material printer if you want to get technical. But four materials is a lot more than two. And with this, you'd be able to mix like 4 different colors of super flexible PIBA. You could mix TPU, PETG, PLA, and carbon fiber nylon. You can get really crazy with the applications for this stuff. And I'm gonna be printing out some more stuff with this machine. And yeah, definitely gonna be throwing away that box because there's no way I'm returning this machine. This one's staying in the print lab for the foreseeable future. Now, we didn't get into all the detailed specs of this machine because I'm sure you've already read those. But to do a quick summary of them, we've got lights, we've got cameras, we've got multiple print heads. One downside of this machine, if you really want to complain about it, is that you don't have a full enclosure here. But I find that I don't typically print with materials that require an enclosure. I mean, really, you're looking at ABS and possibly polycarbonate. With this, I think it's really going to shine at printing things with a bunch of different colors in PLA and PETG, or mixing a bunch of different colors for TPU, which we don't really have any options on the market that can do that super easily and reliably. So yeah, if you want to print out some shoes that have 4 different colors in them, or just some other crazy stuff, this would be the machine for you. All right, thanks for listening to my rant about this machine. I mean, really, it was built on the progress that a lot of other companies and open source projects have made. We've got Clipper in this thing. We've got Orca Slicer in this thing. We've got a Core XY architecture that's very similar to the Bambu Lab printers like the X1C and P1S. We've got a tool changer system that's very similar to what you see on a Prusa XL. And we're using a slicer that's greatly benefited from the advancements that Prusa Slicer has made. At the end of the day, it's not necessarily a bad thing that they're taking from all these open source projects and borrowing ideas from other places, because it seems like they're willing to play ball and give ideas back to the community. Give people the Clipper code for this thing so that you could modify it possibly if you wanted to. Snapmaker seems like they're going to be playing much nicer with all the people that they should be friendly to than maybe some of the other companies in the arena have been. So in terms of an ethical vote, I would go ahead and consider picking one of these up. Now keep in mind, this is a sponsored video, but for me, that doesn't mean a whole lot. If I don't like a machine, I'll tear it apart and say that I don't like it. In fact, Snapmaker actually sent me a machine a couple of years ago, and I hope they don't remember that incident because it didn't end well for the printer. I had some, you know what, let's not get into that. We're moving on a more positive note. Just like Snapmaker has moved on and has started developing some really fantastic products. And I think they all deserve our support because they're bringing something new to the market, unlocking a bunch of possibilities, cutting down on filament waste. I mean, there's just a lot of positives going on here. All right, that's all for now. I appreciate the time and attention that you've paid to watching this video. Appreciate all the support that I get over on Patreon and all the companies that are willing to send me all these really cool machines to try out and play with and try and break and tear apart and all that. I like the printer, and I think you would too. So if you want to pick one of these up, go ahead and click the affiliate link down in the description below. That helps the channel out. Actually, my bad guys, there's one last thing that we need to do here, and that is to run the decibel test. We gotta see how loud this machine is. Since it's unenclosed and it's got some powerful part cooling fans, it might be a little noisy, so let's go ahead and figure it out. 1 arm's length away, let's see how loud we are. All right, so about 50 to 57 decibels. Not too bad for a machine that's not enclosed like this, but you know, it's a little bit louder and on the more annoying side with all the noises and the fan going on. So this would be something that I wouldn't want right next to my desk. So, you know, if you've got a garage or some quiet place to put it, that would be ideal. But the other benefit of this machine is that it finishes its print job so fast. I know there's some multicolor prints that I've set up before, like on that K2 Plus over there, that were set to take 2 to 3 days. So that could be really annoying. You definitely couldn't fire up an overnight print in your office and come back to a quiet printer. With this one, all the test prints that I've ran have only taken about 3 to 6 hours. I could try loading up some really big stuff, but it's got all those time savings built in because of the different way that it changes materials. So I have reason to believe that it'd probably be about half the time. Maybe you could get a lot of prints under 12 hours, and you'd rarely get prints that exceed 1 to 2 days. If you want to see more work like this, go ahead and subscribe to the channel. And if you really like the work that I'm doing, head over to Patreon and give me some support over there. I couldn't keep this channel going without you guys, especially in some periods of time where I'm not publishing as many videos. That really helps even out my income and helps me pay the bills for this office space and run all these interesting experiments. I've been printing a lot of things behind the scenes that I really got to catch you guys up on, so I'll start doing that as soon as I can. And I really appreciate all your guys' time and attention. I'll see you in the next video.